Hi and welcome to Quick Math. This segment will start with what is a one-dimensional object, then move on to basic angle theory in math. So how does one describe a one-dimensional object? It is best thought as a line, but it is not necessarily one needing to be straight or laid flat. Here are some angle facts for lines. The sum of the angles for a straight line is always 180 degrees. And this translates to the sum of angles around a point being always 360 degrees. Also, opposite angles for lines that crisscross one another are always the same. The diagram on the left represents a line intersecting a pair of parallel lines. In such an instance, the angles B1 and B3 are equal and are known as corresponding angles. Also, the angles B2 and B3 are equal and they are known as alternate angles. In order to demonstrate how we can use angle facts, I will take you through this example involving the identification of angle A from the diagram on this page. Here are the steps. Start by drawing another parallel line through the corner of angle A. Next, you break angle A to angles B and C, with one being above and the other being below this parallel line. Being an alternate angle to 40 degrees, the angle of B is 40 degrees. Being supplementary with 135 degrees, the angle of C is 180 degrees minus 135 degrees, which equals 45 degrees. To get to angle A, all you need to do is to sum angles B and C to arrive at the outcome of 85 degrees. Next, we shall start with the sum of internal angles for two polygons which we should be most familiar with. In a triangle, the sum of all its three internal angles is always 180 degrees. In a quadrilateral, the sum of all its four internal angles is always 360 degrees. As for the sum of internal angles of other polygons, they are indicated in the table on the right. You should also notice that the sum of internal angles are in the increments of 180 degrees each time the number of sides of the polygon increases by 1. In summary, the sum of all internal angles of each polygon is equal to the number of sides minus 2, and this outcome being multiplied against 180 degrees. And in circle theorem, when lines are drawn from two ends of the diameter of a circle to meet at any part of the circle's circumference, they would form a right angle. And finally, some basic trigonometry. The diagram on the left shows a right angle triangle with one of its corner labeled with the angle theta. In such a representation, the line at the base is referred to as adjacent, and the line away from the angle theta is referred to as opposite. The longest line on the triangle here, as we already know, is its hypotenuse. With the mentioned references, sine theta is always equal to the outcome of opposite over hypotenuse. Cos theta is always equal to the outcome of adjacent over hypotenuse, and tangent theta is always equal to the outcome of opposite over adjacent. Let's now get on board tutorial question 1, so do press the pause button if you need more time. What is the angle of A on the attached diagram? The answer is 85 degrees, and here's how we get to it. Step 1 requires us to know that the angle at the area is 90 degrees, applying circle theorem. Step 2 requires us to apply sum of internal angles for a triangle. Step 3 requires us to know that when two lines branch off from an end of the diameter and remain equal in length as each hits the circumference of the circle, the diameter line exactly halves the internal angle of these two lines. Finally, step 4 requires us to apply sum of internal angles for quadrilateral. Tutorial question 2. What is the length B on the attached diagram if the radius of the circle is 5 cm? The answer is 5 cm, and one way to get to the answer is to apply basic trigonometry, where b is the product of the diameter and sine 30 degrees. This question is also meant to prove that when a line branches off from the end of a diameter at 60 degrees, it will cut at the circumference at exactly the distance of the circle radius. Tutorial question 3. Do press the pause button now if you need more time. What is the angle of C on the attached diagram? The answer is 70 degrees, and this is achieved by applying angle facts, where the upper portion of the angle C is the supplementary of 150 degrees, and its lower portion being the supplementary of 140 degrees. The final answer for angle C is obtained from the sum of the mentioned upper and lower portions of C. Tutorial question 4. What is the length D on the attached diagram if the diameter of the circle is 5 cm? The answer is 2.5 cm, with D being the radius of the circle. This is all for a segment on one-dimensional objects and angles. Do join us for other segments on quick math if you found this useful.